Now this question is a definite integral because it has terminals. It has numbers on the integration sign. So this is what we do. We integrate it as normal. Add 1 to the power, divide by the new power, and again. But we don't put plus c. Instead, we put the expression in square brackets and write the terminals on the right-hand side. Now that can be simplified, so I'll do that. 2x to the power of 6 over 3 minus 3x squared, and I keep those terminals there. Now I'm going to sub the terminals in. So firstly sub the top one in, 2 by 3 to the power of 6 over 3 minus 3 times 3 squared. Then you subtract and sub in the bottom one. So 2 times 1 over 3, that's 2 over 3. And 3 times 1 squared is 3. And if you put that into your calculator, you will get 461 and 1/3. And now in this question, we're asked to find the integral from 1 to 2 of the function 1 over 3x take 4. So we integrate it, and this one gives us a logarithm. It's the log of absolute value 3x take 4. But it's not just an x that's on the bottom here. It's not just x here, it's a function of x. So since we're integrating, we need to divide by the derivative of that function, which is 3. So we've got to divide by 3. Okay? So that's what the derivative is. And we have terminals again. So we've got terminals 1 and 2, which need to be put on the right-hand side. Now we substitute the terminals in. It's a third log base e of 3 times 2, take away 4. Then subtract, and the same function again, subbing in the 1. A third log base e, absolute value of 3 times 1, take 4. Simplify. That gives us a third log base e of the absolute value of 2 minus a third log base e of the absolute value of -1. Now the purpose of these absolute value signs when we're integrating to get a log is because you cannot log a negative number. And if it wasn't for those signs, we would be trying to log a negative number there and we'd get an undefined answer. But the absolute signs enable us to turn it into a positive number. So what this means is a third log base e, well this doesn't change because it was positive 2 anyway. And here a third log base e, we can take that now as positive 1. Log of 1 is 0, so we've got a third log base e of 2 minus 0, leaving us with a third log base e of 2.